Why bother writing a quadratic in completed squared form? Well, looking at this quadratic, I couldn't tell you what its minimum value is, but written in completed squared form, provided I know what to look for, it's easy. And the coordinate of the minimum point of this equation will be -3, -16. And here's the graph that proves it. So we'll look at how we complete the square. And this method of completing the square works for quadratics that have a plane x squared. It won't work for quadratics, for example, that have 2x squared or -3x squared or even -x squared. It must be simply x squared. So this equation is the correct form, x squared, so we can proceed. Step 1, we write this out, and this will be always how you start. Step 2, inside the brackets, write half the x coefficient. Well, the x coefficient here is +6, and half of this will be +3. Step 3, we square the number we just wrote and put it on the end. So we just wrote +3, we square it to get 9, and we put it on the end. We'll always be subtracting this number, and that's why we wrote the minus in advance. Step 4, bring down the constant from the original question. In other words, the fixed number if there is one. And finally, we'll collect like terms. And that's it. I'll just remind you that the whole point of doing this is that the completed squared form allows us to quickly write the turning point of the quadratic. And in this case, it'll be -3, -16. You can think of it as always being the opposite of what's in the brackets, and the y value is just the number that's on the end.